to do before starting this afternoon session. First, I would like to repeat what I said this morning for those who are not present. Excuse me for the others. The 3 points that every morning and every afternoon of the following days of this week until Thursday, we will have each morning and each afternoon one EAP, WAAP session, which takes place in another room like that one. Monday, that is tomorrow, and afternoon, we have a welcome and award ceremony to support. We have to go to the award ceremony and welcome ceremony to support the awardees of WAAP, EAP, and the sponsor. And Tuesday morning, we have the plenary session, EAP, WAAP. And also in this session, we will hear the two awardees, EAP and WAAP. This is the first 3 announcements that I want to do. The second one is just here to inform you. The local organizers asked me to inform you that tomorrow, Monday, after 8:30 p.m., that is much after the welcome ceremony, there is a reception in the Hôtel de Ville de Lyon. You can register, this is free of course, you can register by scanning this code or by inscription at the welcome desk. Qu'est-ce qu'on fait pour descendre là? So this afternoon session is dedicated to biodiversity as a lever for sustainable animal production, and it will be co-chaired by Michel Rieu here from the French Academy of Agriculture and from Matthias Gauly from University of Bolzano in Italy. As this morning, we will have a small sequence just after this slide to welcome our sponsor this afternoon. The sponsor is the Sommet de l'Élevage, who asked us to present a small video on what they are presenting. So if you have time to watch these 2 minutes of video. If I can. No, it doesn't work. No. I don't know if there is somebody from the technique to help me to do that. Okay, perfect.
Sabah yıkadık diyor, her zaman diyor tarıyoruz diyor.
Da tutta Europa abbiamo questo ragazzo che viene direttamente dall'Austria.
Це гірська місцевість, тому корови та бички породи Салерс можуть виживати і розкривати свій продуктивний потенціал.
And so this year, the Sommet de l'Élevage is from the 3 to the 6th of October 2023. So you can stay 1 month in Lyon, or you can pass 1 month holidays in Clermont-Ferrand if you want. So thank you very much for hearing that. And now I give the floor to Michel and Matthias for the session on biodiversity. Thank you.
Thank you. Thank you, Philippe. Good afternoon to all of you. So the word this afternoon is biodiversity. And we will have a speech about it. The climate change is now not only largely scientifically based, but also very popular in the population, in the public debate. But now the biodiversity issues take more and more importance. IPBES is on stage next to IPCC, and biodiversity appears as decisive for biological equilibrium and therefore for human life. Moreover, climate change and loss of biodiversity are strongly linked. It's why it is important, in order to think the sustainable future of animal farming, to take into account the impact of the farming systems on biodiversity. And like it was many times said this morning, is but be done regarding the context. And the contexts are largely diversified all around the world. The differences are on climate, water regimes, landscape, natural life, but also on economy, sociology, and governance, and different points addressed by social sciences. We can say that assessing the impact of livestock system on biodiversity and reciprocally is not so easy. Numerous research work are ongoing on that. We would like to know to what point livestock systems are damaging or protective for biodiversity, and that's why this afternoon you will have 4 very interesting presentations addressing this issue, 2 before coffee break and 2 after, before a final discussion at the end of the afternoon on the both subject of the day. So, Matthias, you will introduce the first presentation and the first speaker.
Excuse me, there is a mistake here. I forgot to mention that the last speaker will not be there, so that the coffee break will be between Anne Mottet and Anne Mottet. Okay? Excuse me.
Okay. Matthias, you have your mic.
Hello, everybody. Yeah, it's my pleasure to introduce you to the first speaker. I'm really proud that he made all the way over from Colombia to Lyon, this beautiful place. It's Julian Chara, and he's research director of the Center of Research on Sustainable Agriculture. Besides many activities, he is also coordinator of the global network of sylvopastoral systems, and this is exactly what he's going to talk about. Julian, we're happy to have you here. The floor is yours. Please.
Okay. Thank you very much, Matthias, and thank you for the invitation to this important event. I am going to talk about a topic we have been working for a long time, which are sylvopastoral systems, and how we can manage or do sustainable intensification using these systems basically based in Colombia, and with emphasis on Latin America, but with also some information from other parts of the world. First of all, we are, as has been mentioned this morning, we have the challenge of producing more food for a growing population, and in that transition, or in that work, we have been transforming a lot the ecosystems in the world. As Matthias says, the biodiversity is the diversity of life in different forms, from genes to organisms to ecosystems. So it is very important to preserve the ecosystem that we have in the planet. And what has happened is that at least 75% of the land surface has been transformed by human activities. Here in this map, we see the green, which are the forests that are still remaining somehow intact, but some others very perturbed. And also in yellow, we see mainly grasslands and pastures, and on the other color, agriculture. If we sum up all these and put all this together, the livestock production will occupy something like bigger than the Americas, around 50 million square kilometers, which is 5 billion hectares. And of that, a quarter of that is used for producing feed for the livestock. So that's an important user, the most important user in the world. As we are talking about biodiversity and about ecosystems, occupying those ecosystems and changing their cover is one of the main threats of biodiversity, not only in previous years, as has happened so far, but also is one of the main problems in the future. How we are going to deal with the food production without destroying, actually recovering the diversity. Previously, we saw the maps where beef production was. As you see, if we go to the tropics, still the areas where more beef is produced is also where deforestation hotspots are right now. In Latin America, mainly Brazil, Bolivia, Peru, and Colombia are creating a lot of deforestation. But in other parts of the world, this is also important. For the humid forest, that's the Amazon region that we have there, we can see that there is a lot of areas that are being impacted by deforestation. There are the yellow and the red spots there in the map, and they are mainly in Brazil, but as I mentioned, also Bolivia and other countries. But these are like the humid forests. But when we talk about dry forests in the world, the Chaco region, which is the second most important biome in Latin America, is also where a lot of beef is being produced now, and a lot of soybean. So it is also being hardly affected by the food production. And it's very important because the dry forests are one of the most impacted ecosystems in the world. So it's hard that is being affected. And also in Africa, we are some areas where it's going to be more problems with that. In total, we have, during the last 20 years, there have been deforestation of more than 60 million hectares in tropical forests, and that has been mainly caused by beef production, and this color here is Brazil, this is Latin America, the rest of Latin America and Africa. The second is oil seeds that had to do with feed production, also for humans, but for feed production. And again, we are seeing that impact mostly in Latin America, but also in Indonesia and Africa. And then the other one is forestry production. There is destruction of forests to produce timber and other products for humans. So what we have was we see in Latin America and many other countries is the destruction of the displacement of biodiversity or the habitats to produce either beef or soybean, or now more recently the destruction of or the use of land that has been previously in beef production for producing soybean, and then that beef is pushed back to the forest and start destroying more forests or move to other regions. Another important factor is that a lot of that land has been degraded, so it's no longer very productive. But it has, I would say, a hope is that it is relatively easy to restore that land to continue or to increase the production. So in terms of biodiversity decline, I am using this index that has been created relatively recently. That is simply measuring the population of around 5,000 species along this period. And this is showing that, as indicator of biodiversity decline, that they have the population of those have been declining in 69% in average in all the areas that have been measured. And this is mainly with a high degradation in the tropical countries, particularly because what I showed you before, there is a lot of destruction of the forest, but also in other regions. And in some others, that trend is not as bad at least during the last 50 years. But I would like to talk more about the positive thing, of the positive side of that. This will be like the business, well, that's what has happened so far, and that will be the business as usual if we don't do anything to protect that diversity. But if we follow the yellow path, which is increased conservation efforts, as Matthias mentioned before, we had the COP15 of biodiversity last year, and that they were committed to have more resources to protect the environment. And yesterday or before yesterday, there was the announcement that they were the first bunch of money that was promised already effective to start protecting the environment. But this will mean restoring the protected areas and having more protected areas in the world. There is a goal of increasing the amount of protected areas so that specific biodiversity can be preserved. But if we only work on that, there won't be, we'll change a bit, but we won't be able to recover the diversity. To really bend that curve, it is important to change both to sustainable production and sustainable consumption, meaning that we have to reverse what has happened so far in terms of the use of land. Moving to the cattle production system, we have different types of production, from extensive systems, that's mainly what happens after deforestation in many of the tropical countries, that go degraded after some time. There are possibilities of producing beef or dairy or ruminants in better conditions in areas where pastures are better managed, and that's possible, has been happening in several countries now. But unfortunately, in many cases, these areas were previously covered by forest. And if we don't introduce forest into those systems, we'll never recover the biodiversity that was lost there. When I say introducing forest, it's not covering everything of forest, but the strategic areas has to be covered by forest, and the rest of that could be increase the tree cover to improve biodiversity. And on the other hand, we have also the feedlots and this intensive way of producing that, as you see, could be seen as less eruptive of going to the natural systems, but it relies a lot on land in some other parts of the world to produce the feed for these animals, and that also is producing deforestation and degradation. So with that, I want to start introducing sylvopastoral systems that are basically a combination of pastures, including legumes, with shrubs and/or trees and livestock for animal production. So that there is, and I like this definition by Rieu, which talks about the 4 I's, which is intentional integration of trees, shrubs and pastures, with intensive management and intensive interaction. And I want to emphasize on that because usually what happens is that you have to deal rationally with more components than what you usually deal. You have to introduce trees and shrubs, and that implies a better management of the land. So in the sylvopastoral system, there are important interactions between all the components, both below and above ground. And in those components, there are different cycling of nutrients, recycling of nutrients, nitrogen fixation, and an important stuff for biodiversity, which is increased richness of the structure of the soil. When we have this situation, there are only one little strata and the soil for holding animals or plants or whatever. When we have this situation with the trees, then we have not only one strata, but below ground, and only 3 or 4 or 5 strata to increase the complexity of the environment, and therefore in holding more biodiversity. Sylvopastoral systems can be a result of many processes. Some of them, as the one here in the left, are in Kenya above, and in south of Spain, the dehesas, that are the result of traditional management that has made the farmers or the owners to leave those trees there because they knew before that they are necessary and they are used for some type of production, as the case of the acorns in the dehesas. So there are these type of sylvopastoral systems that have been like created by the traditionally, because farmers or the owners there knew that they have to be kept like that. And there are other type of sylvopastoral systems that are more introducing trees for different purposes, either for only shade or cycling in this case, or introducing timber production. In this case, is the cattle who has gotten into the timber production because precisely because of the soybean production in Argentina. The beef production have been pushing toward the north. So they are like interacting with timber production, so which is very important. And in other cases, as in Brazil, we have the ILPF, the Integrated Livestock Forestry and Agriculture system that is promoted by the government and by Embrapa, and has different type of combination between agriculture or animals and timber or trees for production. And of that, Embrapa claims to have 11.5 million hectares of that implemented already, and the goal is to have 30 million hectares by 2030. And they are different combinations, but in this case, there are 1.84 million hectares of sylvopastoral system, which is a combination between either timber and animals, or timber, agriculture, and animals. And then one more type of system in which the shrub is actually produced for being directly browsed by the animals. And in that case, there are few species that tolerate that. The main one is Leucaena leucina or Leucaena leucocephala, which is grown in dry tropical areas. And here we also have Tithonia diversifolia, which is a plant originally from Central America that is also utilized by the animal and tolerates the browsing of the animal. And the most important example of in terms of extension of the use of this type of system is in Australia, in Queensland, where they have over 200,000 hectares of this combination, and is now used as a way to become carbon neutral in the beef production in Australia. And there are some I would say, novel systems that are being either increased or being taken again by farmers in Europe, of several of them with apple orchards, and also combining, and it's important to see, combining other animals in addition to beef, to cattle. Particularly this system in which pigs are also left to browse and to eat the acorn of this tree in the Dehesas and Montana region in the Iberian Peninsula. And finally, the linear systems that are also very important in some other regions of the world, particularly windbreaks in the United States, are common sylvopastoral system has been used for a long time, and also hedgerows in UK that are traditionally kept there for different reasons, and still there is a huge amount of area on that systems. In this case, there is an interaction between the grass in the middle and the effect of the trees around the system. So if we want to improve biodiversity in productive systems, it's important to have different strategies. One is to increase the productive efficiency to reduce the pressure on natural environments. That's the main one that we try to use when we deal with areas that have been degraded, because it's possible to improve production in one area of the farm and release areas to protect the environment. Also, reducing the destruction of timber and forest products, that's an important issue that causes deforestation in areas with cattle production, because they have to be fencing and replacing the fences periodically. And therefore, having a sylvopastoral system that has the fences, the live fences, reduce that problem. Also reduces the need or the use of pesticides. The main causes of biodiversity depletion at the moment are first climate change, that is changing the temperature has affected the animals. As we saw yesterday, probably in the news, you saw that there was the frost of an area in the Antarctica, and now the chicken of the penguins are not able to complete their cycle before the melting of the ice. So that's an important one. The other one that I mentioned already was the change in the habitat. Another important one is the use of toxics or pesticides that are killing many animals, particularly insects. And there are many direct strategies like increasing the amount of trees in the system, and also using it at landscape level for connectivity. And here there is an important interaction between what we saw this morning regarding carbon capture and the possibility of reducing the impact of cattle on climate change. So in terms of increasing efficiency, I just want to mention that when you introduce this type of system with better feeding, you increase the possibility of, the production of dry matter, and also the quality of that dry matter, meaning that you can increase also the stocking rate and reduce the area you need for production. Of course, there have to be policies to avoid the increase of that area because of the higher productivity. Here is an example of what could happen if you manage change from this system to a system in which you introduce sylvopastoral system, in this case with leucaena. There is the reduction in the need of nitrogen fertilizer is not used, and for that you can increase the productivity from 20 to 30 tons of dry matter per hectare per year, or 25% of increase. Then the stocking rate, the daily weight gain of heifer, and also the production. In this particular case of this farm, they moved from these 2.5 thousand kilos of milk per cow per year to 3,000. And as they increase the stocking rate, there is almost a 50% increase in milk production. That is a strategy that we are trying to use to reduce the areas that are being used by the farmer, because usually there are areas that have to be put under restoration because they are wetlands or forests that need to be restored. I'm going to mention briefly what we have done also in methane reduction with this system, and it also has to do with the fact that of having diversity of systems there. So when you introduce these shrubs in the system, either leucaena or Titonia diversifolia, you can also reduce the methane emissions. We measured with these chambers, and what we have seen is a reduction in the methane when you introduce the leucaena as compared to the traditional system, and also an increase of carbon capture in the strata. So the same strata that helps increasing diversity or increasing structural richness in the system are those who can have more biomass, main roots, fine roots, pastures, but also shrubs and trees that are the ones that are responsible for having more biomass and more carbon stock in the farm. And for Titonia diversifolia, which is the shrub I mentioned, when you introduce it, it can increase the productivity either of milk or protein or fat in the milk. So this is an increase with this type of animals we work there, and also a reduction in the emissions. in the methane emissions when you introduce it. And this is the result of having used a plant that was in the system, that was, they say, traditionally used by some farmers and indigenous peoples in the area, that we saw as a promising forage that could be used for these sylvopastoral systems. And also, with the systems, this has to do with the diversity of organisms in the soil. You can also reduce the emissions from excreta, both in the manure and in the urine, due to when you have these sylvopastoral systems. In general terms, we believe that it has to do with the richer biota in the soil. And here I want to show some research regarding carbon capture, animal welfare, and biodiversity done in some other parts of the world. In this case, it's a paper that was released a few days ago, that has to do with the goal of the UK to increase the hedgerows. The idea is to increase by 40% the amount of the length of the hedgerows in the country, and with that, this paper makes an analysis of how long it will take to accomplish the goal of reducing the emissions of agriculture in UK. And you can see here that if they continue at the current planting rate, it will take the amount of carbon capture will be this amount. But if they grow to a higher speed, they will get that increase faster. So the idea is that they can reduce to offset 4.5 to 6.2 percent of the UK annual agriculture emissions. And that's how sylvopastoralists can also use it. And importantly, the analysis was done measuring at least 10 different species of plants that are used in the hedgerow. So it has to do also with the diversity of the system. And in the case of Australia, they also are gaining in terms of efficiency. So here, when they introduce the leucaena, they can increase the stocking rate, increase the animal weight, and increase the production per hectare. And this also has to do with the reduction of the need of area for the system. These are the growth rate of the animals with and without leucina. And in these scenarios, they show what usually happens with the buffalo grass. What happened in the scenario if they continue with the same number of animals? They will keep the same number of animals, but the amount of emissions will be reduced. If they keep the same living weight, the amount will be even reduced further because the structure of the hair will be better. And if they have the same emissions, they are able to produce more. So there is a way of showing that it is possible to move from in different scenarios. One in which you can reduce the production, but keep the production and reduce emission, or one in which with the same emissions we can produce more, and that's another way of releasing land for diversity. So in the sylvopastoral systems, well, as I mentioned, there are like more structures and resources for the animals. In this case, birds, and you can see the use of those by birds in the system, and are also important to contribute to connectivity of the area. One important thing is that sylvopastoral systems by themselves are not going to protect the diversity. It's important to always protect forests in the farms. And in this case, for example, at landscape level, there are corridors that we can protect, and sylvopastoral systems can also contribute to that connectivity in the area and to increase the productivity here to avoid the destruction of this forest. And this is the meta-analysis that was done recently, measuring the effect of sylvopastoral systems on biodiversity around the globe. Importantly, most of the papers that we could gather are from the tropics, mainly in Brazil, Colombia, Mexico, and Central America. There are some from the subtropic in the south of South America, and also from the Mediterranean and temperate sites that we were able to obtain those papers. What we found is, first is that most of the papers are dealing with insect diversity, but also there are many other taxa that are considered for the diversity. That sylvopastoral systems have a positive effect on diversity as compared to treeless pastures. So increasing the pastures at different levels, at different regions, can increase diversity, either in richness, abundance, or diversity, so that we can revert the situation that I mentioned that is happening with the diversity around the globe. So this shows that the sylvopastoral has a positive effect on that. The second column shows the comparison with forests, and they are either a bit lower than forests or similar, but it has to be taken into account that forests keep a specific type of fauna that has to be preserved, fauna and flora that has to be preserved, and it's not possible to reproduce that in sylvopastoral systems. So they are complementary. And in terms of the regions, usually there is, when compared with pastures, there is a trend to either maintain the diversity or increase it. The overall effect along the regions is to increase a bit the amount of dung beetles, insects, and macroinvertebrates, not so much mammals and birds, and increase the diversity of plants. And when we measure it relative to natural habitats, there is, sylvopastorals are not as good as preserving diversity as the forest, but can be a complement in some of the taxa. So this shows that at different level, both in the tropics and in the subtropics and temperate sites, they contribute to improve diversity if they are converted from treeless pastures or compared to treeless pastures. Also, because of this structure, they contribute also to animal welfare, and that's very important in terms of climate change. Not only because they can contribute to the welfare of the animals, but also because when they protect the humidity and temperature here, they will reduce the impact of climate change. In this case, we are showing the two measures of heat and humidity in the systems, comparing the intensive rotation with sylvopastoral systems in Brazil. This is one of the systems in Brazil, and it is always around 5% or 10% is cooler if you have sylvopastoral system than if you have the open system. In terms of temperature in the animal, this is the backline temperature, both for heifers and for cows. Is most of the time is smaller, is lower from, you have 34 degrees if you don't have the sylvopastoral system, and 3 degrees less if the sylvopastoral is there. And also in terms of growth of the animal, the heifers continue growing relatively well if they are in the sylvopastoral systems. Well, and it has been related in this research with the temperature comfort. And in the case of cows, they can keep the weight along the season where it is warmer there. And this measures the amount of cortisol in the cows, and is also reduced when you have sylvopastoral systems in the warmer side areas. This means that if you have 3 degrees less in the system, you are somehow compensating for the increased temperature that we are having now. And also this paper was comparing sylvopastoral systems in Colombia, Brazil, and Africa, measuring the amount of carbon, the amount of above ground carbon, and let's say, buffer capacity it has for temperature. And what it's saying here is also that they are able to counteract most of the heat that is going to happen that is modeled that will happen with the climate change in these regions. So introducing sylvopastoral system here at the biomass that is proposed in the paper will also increase not only the positive effect on cattle, but also the positive effect on diversity, because the temperature will be lower and the humidity will be higher in those areas, compensating what is happening with the climate change. So to finish, I'd like to mention that first, sylvopastoral can contribute to reduce the negative impact of cattle production on the environment and serve as a potential as restoration of biodiversity in degraded lands. That biodiversity can provide benefits for the production, such as carbon sequestration, improved productivity, and some other ecosystem services related mainly with water preservation. It's important to combine sylvopastoral system with protected areas to complement the impact of protecting those areas, and they can contribute to increase productivity, efficiency, and reduce the emissions of cattle production. Having said that, it's important to mention that even when there are many positive effects, both in terms of climate, animal welfare, and diversity, has been difficult to implement or to increase the area under these systems. Nowadays, they are committed in many of the national contributions and NDCs for Latin America, and they are policies growing to increase their uptake, but there is still many barriers to their implementation related mainly to the lack of knowledge about it, and the cost and complexity that it could have. So there should be a lot of work under that side of increasing the policies and the mechanisms that will allow to increase the adoption of the system. Thank you.
Thank you very much for this very interesting talk. If there are any questions, please stand up and go to the microphone. I'd like to start with the first question, Julian. Do you have any clue about the economical point of view? Is this competitive with a specialized system?
Yes, I didn't show, but we have analyzed this in several regions, including Argentina, Brazil, and Colombia, and usually they are more profitable than the conventional system, either if it's compared with a conventional system with intensive management with fertilizers, or with a conventional system with an extensive management that is not very efficient. So they can increase the efficiency and increase the profitability. The issue, however, is that the initial investment is high, so there is a period of 3 years, 2 to 3 years of negative cash flow that has to be compensated by loans or any other thing. So that's.
And if you compare different species in the system, from beef cattle to dairy cows to sheep, goats, would you give any preference to one of these species, or would you say it works for all?
It works for all, but you have to if you are going to use small ruminants, the design should be a bit different, and also somehow the species and the pressure you put on the pasture, because there will be a possibility of that the beef or the sheep or goats start eating the cover of the trees.
Any questions in the audience? Philippe?
Thank you, Julian. Is it possible to imagine to continue to complicate the system with other species like fishes or monogastrics or in this sylvopastoral system? Because you mentioned mainly ruminants, as far as I know. And do you imagine that you can continue to increase the number of species, for example?
Yes. That's a very, very interesting question. We have been dealing with systems in which we try to promote the trees that are more eligible by the farmer, and are easier, easier for him to adopt those trees because they know them or something like that. But in some cases, when we have to measure what will be the most important in terms of economic return, then you have to think of trees that have higher value and that are being could be harvested. So that's one point. And the other point is that the higher the diversity, I will say the better the results in terms of the cycling and all the benefits you get from the system. You have only eucalyptus happens in some places. There are not as much benefits as if you have different timber trees. But it makes it more complex. That's one situation. It is when the farmer has had some tradition of using those trees and knowing something about timber management, that is relatively easy to deal with. But the farmers know we have that complexity of thinking. And the final perhaps is when for the farmers who have been already managing very well their farms without trees. Introducing trees is a very relatively easy process because they know the benefits, the savings they are having from that. When as it happens in many situations, the farmer doesn't have enough knowledge of how much he's spending in the farm, like it could happen. Introducing these trees is seen like a more complex thing that will be more expensive, but in real terms it provides more benefits.
And in Colombia, do your government give incentive to cover these 3-4 years of negative productivity? Or?
Yes, with a project we run from 2005-2010, we convinced the government to provide an incentive to implement the system if it had certain density of trees above 300 trees per hectare or 3,000 shrubs per hectare. They will receive an incentive, meaning that the 40% of the interest rate will be returned to the farmer. However, that's something that is being refined at the moment because there is no, farmers are very reluctant to have credits, and for having this incentive, they need the credit. So there are some ways to have some other incentives that are more attractive to farmers without going to the bank.
Thank you.
Thank you. Thank you very much. There's 2 more questions, please.
Tim McAllister from Canada, great presentation. I'm just wondering what climate change impacts on the severity of fire. We've been having really bad forest fires in Canada, as I imagine everybody's heard. How is that going to affect the ability to establish these silvopasture conditions, or will it?
Very good question. I was talking with some guys from Queensland, precisely, where they were impacted by some fires last year. And I would say that usually the system has to be protected for forest fires. In that sense, having, for example, during the season where the fires could happen, there has to be a higher intensity of grazing to avoid having a lot of biomass, and some other measures that are very important. Another action that is being taken in Argentina is as you have to have the water for the cattle in all the paddocks. There will be more available water to protect from the fires when they are not as hard, you know. So that's the answer I have for that.
Thank you very much. There's one more.
Thank you very much for the very nice presentation with very clear scenario of the production systems, especially with beef cattle. Whether you have launched the project with dairy cattle, especially in your region, because recently I have got information from friends from Colombia telling me about the high cost of production, especially from the feeds, whether your approaches have been launched to help these stakeholders in the region or not. Secondly, with the reports that emphasizing on the use of phytonutrients in many fodders, tree shrubs, you know, selection on your project has been, more to determine the selection or potential of these species into the system in order to provide not only the nutritive values, but the phytonutrients to condensed and supplements, as an example. Thank you.
Thank you. First, I forgot the first question. Okay, yes. Actually, the only figure, economic figure the experiments that I show, both for the economic performance and for emissions, are from dairy cattle. And we have worked with systems that are very intensive with that, and in that case, replacing 30% of the commercial feed by the legume or the shrub in the case of Titonia. And in the one that I show, it was another one that I show. Sorry, they didn't use any feed for the cows because they were only 3 or 4 liters per day, but they managed to increase the productivity by 30% more or less with the introduction of either Leucaena in the north of Colombia or Titonia diversifolia in the wet area of Colombia. And related to your second question, yes, we have been, well, we studied before many of those trees, but I have to say that for those trees that are used for direct browsing by the cattle, the most important thing is that they recover as fast as the grass, and that they tolerate browsing without breaking or destroying the tree. So we started with a lot of species, and we have ended up with 4 now that we are using for that. One is Sambucus peruviana in the high mountains that is also present in Europe. Titonia that is more for acidic soils, and there are more so appropriate for many regions of Colombia that are with more rainfall and lower pH value of the soil, and Leucaena that is more restricted to dry and low land areas.
Thank you very much. Please give Julian a hand again, and then we hand over.
So, our next speaker, you know her already, is Anne Mottet. Anne is an agroeconomist. She used to work for the United Nations Food and Agriculture Organization, and she moves this year to the International Fund for Agriculture Development, another UN organization. So, Anne, you have the word, please.
Thank you, Michel. So thank you for this topic. Sustainability of low input livestock system. It's a wide topic. I'm going to look at biodiversity, obviously, but not only, because the assignment was to talk about sustainability. So first I'm going to look into proposing a framework, a way to look into sustainability, and to compare low input system versus high input system, because we need a bit of a framework, a bit of a methodology to address this question. Of course, we cannot really look into inputs and low inputs or high inputs without talking about food loss and waste, but we already tackled this a little bit this morning, but we're going to try and look into it from the lens of low input systems. And then for the environmental sustainability, which is going to be a big part of my talk today, we're going to look into climate, biodiversity, and land in particular. But I would like to move after that from single metrics to what we call now multi-criteria assessments in order to look at different dimensions of sustainability together and not isolate those different metrics. And finally, because I'm working now for the International Fund for Agricultural Development, I'm going to look into the impact of specific investments that we have at IFAD in low input systems and what they mean in terms of the impact for the farmers. So the framework, I don't need to introduce that. You're all familiar with the 17 Sustainable Development Goals of the United Nations. They're very consistent, they're very useful for not forgetting just one dimension of sustainability. We have 17 in total. That's a bit cumbersome if we want to review all of them. So usually what we try to do for livestock, and this is valid for different, I would say, fora. You can see listed on the right-hand side of this slide. We simplified this when I was working in FAO into 4 areas of priorities, which are food security and nutrition, livelihoods and economic growth, health and animal welfare, and finally, environmental sustainability, climate and natural resource use. So you see, this is a framework that has been used in different fora, including, for example, in the EU, for the study Future of EU Livestock, that was conducted by Jean-Louis Perrault and Michael MacLeod. And this is what we're going to use. But first, so how can we say what is low input? So don't laugh at me, but I actually ChatGPT'd low input system to try and see what comes up before even looking into the literature. So the top part is actually what I got from ChatGPT on low input systems. So it refers to extensive or traditional systems, systems that rely more on local resources and less on external resources like feed, energy, or synthetic agrochemicals. And then a bunch of, I would say, big words or types of systems, sometimes practices, but also concepts that came up, like rotational grazing, diverse forage sources, enhanced animal welfare, cultural and local knowledge, resilience to climate variability, and community engagement and employment. So I was particularly interested in the fact that it didn't only bring the resource part, but also all the social aspects of those systems. That means that in the literature and all the material that is available online and that AI can pick, we actually find a lot of low input system being associated with a social system. So for example, community engagement and employment, or cultural and local knowledge. So what I didn't find in this approach, and that I think is important, is that first, low input is not synonymous to small scale. For example, pastoralist systems, which can be between 200 and 300 million people in the world at the moment, we know they use large areas of land, so we cannot call them low input in terms of the resource land. We know that they are also labor intensive, but they're generally low in capital. So the definition here needs to be inclusive of these kind of systems. And also something that didn't come out too well is that low input is and has to be context and regional specific. It depends on which is the resource that is locally lacking. It's not always the same from one place to another. It can be land, it can be water, it can be labor, or it can be all of them. So there are already tentative mapping definition of the systems. This is from, again, the FAO, from the Global Forum on Food and Agriculture 2018. And you see here a bit of a mapping of all livestock systems based on land, labor, and biomass intensity. Everything that is between yellow and red is intensive in terms of capital. Everything that is blue to purple is intensive in terms of labor. So you see here we have a very clear separation between high-income countries and low- and middle-income countries. And then the green systems are the systems that are intensive in terms of appropriation of biomass. So this is the framework that, you know, a priori we could say we can use to look at low and high input systems. What are the strengths and weaknesses of low input systems compared to high input systems for each of the 4 areas of priority? So if we look at livelihoods and economic growth and income, low input systems, they usually have lower cost of production. They usually have higher self-sufficiency, and therefore they have less exposure to the variability of cost of production from the global market. So one could say that this is a factor for having higher resilience, especially to market shocks. We could think that they might be connected with shorter value chains, but in a lot of cases, and because a lot of low input systems are not low input by choice, but because they have less access to inputs, they also have lower access to market, and they benefit less from the growth of the livestock sector. In the second area of food security and nutrition, well, one important fact, and we all agree on that, is that animal source food are critical to closing the nutritional gap, especially for the rural poor in the world, which are all low input systems, or almost all of them. But they can be also perceived as having lower productivity, and therefore contributing to the supply of animal products to a lesser extent with lower availability of products. Do they have lower food loss and waste in their supply chain? This is a question we can ask. Moving on to the priority area of health and animal welfare, parts of the low input system, and we heard a lot about some of the systems by Julian, the ones that are more extensive or more integrative of trees and pastures, for example, they have higher resilience, higher reliance on pastures and rangeland, and therefore, for some of them, they are more exposed to climate shocks, to droughts, for example, or to heat stress. Maybe they're more exposed also to interaction with wildlife and therefore to the diseases that could pass from wildlife to livestock and then potentially to humans. Those systems tend to have also lower concentration of animals and lower risk of antimicrobial resistance, because they have less use of inputs such as antibiotics. Some of them, not the extensive ones, but maybe the backyard system, they might be more exposed to disease outbreaks. For example, if you think of avian influenza and backyard systems. And also, because they're low inputs, they have lower access to vet services and medicines. And finally, but we're going to look into that into more details, when it comes to environment and climate and natural resources, usually those systems, we could think they have lower use of natural resources. Maybe they rely more on recycling of biomass and energy, but they are also perceived to be less efficient. And then the question is, how do we measure the efficiency? Which production factor are we considering per hectare, per animal, per person, per dollar invested? And maybe also we could say that some of them contribute more to the preservation of biodiversity. So I'm going to look at countries broken down between middle and high income countries in blue and low income countries in green. And the first observation that we have is that when we look at protein production from livestock, it's almost equivalent between those two groups of countries, except maybe for meat. You see, we produce about twice as much meat in middle and high income countries than in low income countries. But for the other types of commodities, it's almost balanced. Then we look at the same breakdown, but for food loss and waste. And there's a recent study from 2019 that is building on the previous work that was available from FAO, saying about 30% of the food we produce is lost in the global food system. They produce this breakdown between those two groups of countries, and the percentage that you see for each commodity at the top of the bar is the share of this commodity produced by this group of countries that is considered lost or wasted. So you see that animal products are a bit lower than other commodities. You see dairy products in middle and high income countries, it's about 12% that is lost or wasted. And you see that the figures are quite the same in terms of percentage between those two groups of countries. But what is very different is the place in the value chain where this happens. You have way more blue on the left and way more red or green even on the right. That means that in low-income countries where we assume here that we have lower input system, it's at production stage that we're wasting and losing a lot. And in particular, I think an important factor of that is not only how efficient the value chain is, but actually, for example, for livestock, animal health. If we have animals that are sick or that have parasites, then they produce at a suboptimal level, and this is considered a loss. So I'm not going to go into the details here, but just for the environmental dimension of sustainability, I'm going to use this framework that was proposed by Bill et al. In the Journal of Nutrition, looking at the role of animal source foods in healthy and environmentally sustainable diets. And in this paper, we looked at 5 priority areas, again, for environment, climate change, biodiversity, land use, and water and soil. This is going to be presented in more details tomorrow morning in session number 2, Sustainable Livestock System, by Lutz Merbold. So, starting with climate, but we're going to go quickly because we talked about this morning, but this time from the lens of the low input systems. do they have higher emissions? So we saw this morning in Dominic's presentation that if you look at emissions per kilogram of protein or emissions per animal, well, you have a very high coloring on the map on the right-hand side. This is from the GLIM dashboard. And you see that, for example, systems in sub-Saharan Africa or in South Asia are quite intensive. That means they emit a lot per kilogram of protein. So this is a common exception. But if you remember the map of emissions per hectare, what we see is that they're actually way more diluted in this map, and then the picture completely changes. So what I think the message here for low input system is that there is growing evidence on the fact that we have inadequate models at the moment to estimate emissions from tropical low input systems. And that might even be the case for not tropical, for temperate low input systems. And I'm just using a couple of examples here. A paper for Senegal, for West Africa by Assouma et al. From 2019. There will be a presentation of this work by Abibou Assouma on Wednesday afternoon, if you're more interested. Overestimation of tier 2 enteric methane emissions in these systems, because mostly we overestimate the feed intake and we completely forget that there's a dry season when animals are not eating at all. Similar results for East Africa, a paper by Philippe Ndungu from 2018, actually that's a mistake, and similar conclusion, we overestimate tier 1 in this case, enteric methane emissions. But we have also interesting results in terms of N2 emissions, again from East Africa, where we might actually underestimate those emissions from this last paper here. So coming on to biodiversity, I think an important point is that it's multifaceted, and that means it can be tackled, it can be approached by different angles. So, of course, one of the main drivers of the losses of biodiversity at global level is deforestation. And a lot of this is for feed production or pasture expansion, we know that. There's also the question of invasive species. So we're talking all the time about improved forage and fodder species varieties. We're using a lot of, for example, Racaria has been spread all over the world now. It's considered a very high potential fodder for tropical livestock. But in some cases, we're actually introducing species that are not endemic and that are actually in competition and responsible with local varieties and responsible for losses of biodiversity. So there's always a trade-off here between productivity and biodiversity. If we think about systems like pastoralist systems or more generally speaking, grazing systems, there's always a trade-off also between their productivity and the grazing pressure, and in many cases, overgrazing. So that's mostly in tropical areas. And then in temperate areas, with a decline in the national herds, like we see in Europe, but also in Central Asia, what's happening is that you have displacements of the grazing pressure, and actually large areas are undergrazed. And you have afforestation, natural afforestation, usually monospecific when it comes to Europe, and also losses of biodiversity compared to higher grazing pressure, I would say moderate grazing pressures in those environments. A very important part for low input system is this question of conservation of animal genetic resources. The way we support those systems to become more productive, in a lot of cases, is by crossbreeding with more productive animals compared to their local breeds. And then there's a high risk of losing this diversity, which is part of biodiversity, the managed biodiversity, and losing resilience because we have animals that are, for example, less adapted to droughts or endemic diseases. But what's important, I think, is to broaden the scope of assessments. We talked about agricultural biodiversity, but how do we measure the impact of systems on what we call unmanaged biodiversity? So if you ask an ecologist, he will tell you we can go and measure things on the ground. We have species that are actually representative of a certain level of biodiversity, but you cannot always do that. And we need proxies, we need way to estimate or model in a way the impact on biodiversity. And I'm just citing here an example that was recently conducted in Kenya using an improved indicator for the FAO tape tool. I'm going to come back to that later. Looking at a number of proxies of drivers like land use change, the size of the patch, whether there are habitats of trees around, whether you have other forms of semi-natural habitats, for example, ponds, but also the amount of fertilizers that you apply. This has an impact on biodiversity. And the stocking rate. So all those, I would say, proxies or indices that can contribute to basically designing a simplified way of measuring the impact of low input systems on unmanaged biodiversity. So now I'm going to move on to land and feed. That's a critical topic for low input system as well. So here you have the contribution of monogastrics and ruminants to global protein production, broken down by systems. And you have, for example, on the left with the ruminants, grazing systems, so large ruminant grazing systems or small ruminant grazing systems, which can be considered low input based on the definition used here. And you see the feedlot, the red part on the top, that is quite small. Beef feedlot actually contribute a small part of global protein availability from ruminants. And on the right-hand side, you see that you have the same kind of breakdown for pigs and poultry systems. But in that case, I would say that low input systems have a lower contribution to global protein availability. So you see that, for example, backyard systems at the bottom for monogastrics or at the top for pigs, but also intermediate pig systems. In total, they're even less than 25% of global protein availability from these systems. So we don't find the low input systems in terms of global protein availability in the same way between ruminants and monogastric. But what we see is that both ruminants and monogastric contribute about the same amount of protein food. But they don't use the same amount of resources. So first, looking at monogastric versus ruminants, you see that for 1 kilo of protein, you need about 133 kilograms of dry matter per kilogram of protein for ruminants, and 30 only for pigs. So you could say they're more efficient. But if you look into this feed and you see, well, we're going to separate what's edible for humans and what is not, because that's the role of ruminant. We said that this morning, to transform feed that we cannot consume ourselves into high quality protein. You see that you only use 6 kilograms of edible dry matter for 1 kilogram of protein from ruminants versus 16 for monogastrics. And then if you move to the very last column, when we look at the protein in ratio, the ratio of protein in and protein out, so how much kilograms of edible plant protein do we need to produce 1 kilogram of animal protein? Well, it's 0.6 for ruminants and 2 kilos for monogastrics. So that means ruminants at global level, they do turn non-edible protein for us into edible protein. They contribute positively to the net, I would say, availability of edible protein. So now, going back to low and high input, we can go even further. So thank you, Jean-Louis, for proposing a chart, but actually I'm sticking with my table because I'm more comfortable with that. So sorry for the very busy table here, but it's not too hard to read. We can look into the same logic, ruminant versus monogastrics, looking, for example, at ruminants in non-OECD countries at the top, and comparing grazing, mixed, and feedlot system. So if we consider grazing our low input, by the definition they are in this case, you see that we need about, the figure in red, a bit less than 1 kilogram of human edible feed, of cereals basically, to produce 1 kilogram of meat, and in feedlots you need about 8 kilos. So those are the figures that you don't always find reported. And then when you move at the last column on the right, that comparison of systems to how much they contribute to the net protein availability, you see that grazing systems are even more performant than the average ruminant system, because they only need 300 grams of edible plant protein to produce a kilo of edible animal protein at global level, an average at global level. So quite efficient when you factor in the edibility. And you find the same logic in poultry, for example, in OECD countries, when you compare backyard to layers of broiler systems. When you see at the very last column 0.5 kilos of edible plant protein per kilogram of animal protein, because those systems, this time it's not about grazing and fodder that we cannot digest, but it's about recycling waste, swill from the agri-food industry or from the kitchen, very simply. So finally, how does this efficiency, non-efficiency of feed translate into hectares? On the left-hand side, you have the whole area of land and the breakdown between forests, other use, and in yellow and green, you have the agricultural land. So you have in yellow agricultural land that is not used for livestock, and in green, the agricultural land that is used for livestock for grazing and feed. A big part of this area is actually composed of pastures and rangelands that are not convertible into cropland. That's the top part, the dark green part. Then you have an area, a large area as well, that could be converted to crops. So there you have a competition with food, but with the loss of other environmental services, ecosystem services. So what you see here is basically what kind of land is used by which system. So ruminants, especially low input system, they use mostly grasslands, and a large part of those grasslands are not convertible, about 2/3. Whereas versus monogastrics, especially industrial monogastrics, which represent more than 75% of the protein from the sector, use actually arable land, like you can see on the right-hand side, whether pigs or chicken, the hectares of cereals, most of the hectares used in those systems you see are yellow, and those are cereals. You also get a bit of hectares from oilseed cakes. So we looked at those different dimensions, climate, biodiversity, land, but I think an important point to make is that we need to move forward with multi-criteria assessment. We want to assess things not in isolated way, because we always find trade-offs between the different dimensions. So here I'm just referring to this tool for agroecology performance evaluation of FAO. Not only because I was working in FAO before, but also because we're using it in IFAD, as you can see here, for example, in Lesotho, to assess the impact of our investment, especially in low input systems, on different dimensions of sustainability. And here I'm just going to quickly present some data from a sample of about 3,000 farms in 9 countries of sub-Saharan Africa, where we use this tool to assess the impact of those projects. So what kind of data do we have on livestock and on inputs in this model? We have, for example, the diversity of livestock, and you see the distribution of farms in those 5 classes that are part of the tool, from no animals to more than 3 species with different breeds. And in the middle, most of farms are actually 2 or 3 species with a few animals. This is a typical low input farm that has livestock in sub-Saharan Africa. And then when you look at the use of external input, which is one of the parameters that is looked at and that is measured, we see that we go from all inputs are purchased from the market to some inputs are produced on the farm or exchanged within the community, and the rest from the market, and then complete independence from the market. And what we see is that first, when we plot the farms by diversity of animals and external inputs, you see that the higher the diversity of animals on the farm, the less dependence on external input we find in this sample, except for farms that have no animals at all, where we find that the dependence from external input is comparable to average diversity of animals. But it's a small sample in our global sample. What we find is also that farms with higher animal diversity, and you can see here from 0 to 4, have higher scores of resilience. So we have a very wide spread out of the farms. You see the distribution here for each of those categories, but we still find what it seems to be a correlation. And the resilience in this case is measured through the stability of income over time, the capacity to recover, the existence of social mechanisms for resilience, environmental resilience and the capacity to adapt to climate change, and the diversity of production and services on farm. So you see more diversity of animals, more resilience. Same thing with, logically, the less dependence on an external input, the more resilient the system. And I think this is, again, it seems to be a link that we find. We have to go deeper and see whether this is confirmed in other regions, for example, or with larger samples, but we do find interesting links here. And before I finish, I just wanted to speak a bit more about those investments. So you saw how we try to assess their impact. We report on the impact on emissions. We report also on other criteria. But what does it mean? How much do we have? What does IFAD do in this case? So you see here the portfolio of IFAD. We have, for example, in the ongoing IFAD portfolio, about 231 projects for about $8 billion in the world, and livestock projects that are labeled livestock are about 15% of this total. This is different from one region to another. 15% is increasing. It's still too low compared to the contribution of livestock to agricultural GDP. I think we should reach at least 20 or 25%. But this is just to show you the kind of portfolio that we have. And within this portfolio, what do we do? Where do we invest? So IFAD has loans or grants with the ministries of livestock or agriculture in the country to support those different areas. And you see one of the biggest is almost 20% is investment in rangelands and pastures. So very low input systems. Then in purple you have pastoralist support services. Again, quite low input. Post-harvest, so the red part is the development of the value chains. For example, milk collection centers, where we support the equipment of milk tank to reduce the losses of milk, for example, and to reduce food loss and waste in those dairy value chains. And you see animal health and animal husbandry, including feed, is also an important part. Quickly, one example of an investment of about $40 million for 25,000 households in Kenya and 600 dairy groups, the smallholder dairy commercialization program, where we worked on training dairy groups on those value chain aspects to conserve the milk and process it and transport it. But also technical support at farm level, very important to develop dairy production and actually increase the access of those farmers to high quality inputs and developing the milk marketing chains. And what you see here, we measure the impact in terms of production through this project. At the end, we measured an increase of 8% of improved grazing practices, plus 25% of vaccination services, plus 12% of use of artificial insemination, and in terms of market access, plus 37% of production, and the price of milk that was increased by 31% in our sample. Another example here, livestock was part of a project. It was not a project that was labeled as livestock, but a value chain project including livestock. The income from livestock in this case was almost double, and what was very important is also an increase, small but still measurable, of 6% in resilience through the diversification in income resources. So this is just a couple of examples from the impact assessment that we have. And just to conclude, and I think that's important for us, what we're trying to do at the moment is to show that investing in low input livestock for better income and better nutrition of the poorest livestock holder in the world doesn't have to increase greenhouse gas emission, doesn't have to result in losses of biodiversity, and we're equipping IFAD at the moment to be able to measure that. So this is, for example, the case in a livestock project in dairy in Kyrgyzstan, where we measured with the tools of FAO like GLIMAI, an increase in production can also be a decrease in absolute emission and a decrease in total dry matter consumption. Another example in Lesotho, where we use the tape tool, as I mentioned before. And I'm going to stop here, and we have a few examples of how to measure the impact of investment in low input systems. if you're interested, there's more information online. Thank you very much.
Thank you, Anne, for this very nuanced presentation, very rich presentation. We have time for a few questions. I have one to begin, if you want. Yeah, okay. My question is about assessment of the impact of biodiversity, and you have to convince financial institutions, I mean, and they are very sensitive to dollars more than other facts. So how do you argue for biodiversity, for the effect of biodiversity on of the project, for example?
Well, I think we don't really have to convince them, because it actually comes now as a requirement. Whether IFAD or World Bank or any other financial institutions, we are all now forced to comply with more and more strict constraints. And for example, in IFAD we call them SECAP. It's social, environmental and climate change assessment performance. So we have to be able to have indicators and to report regularly on the fact that our investments are empowering for women, they provide employment for young people. On the environmental side, they have different criteria, including biodiversity, that is becoming more and more specific, and on climate, that emissions are not increasing or not increasing too much. And so it's a requirement. We don't really have to convince them that it's important. We actually have to find the ways and the tools to be able to do that. And I think we've reached a point in climate where it's very, I mean, it's easier than it was. We're in a better position, we have more tools for that, but biodiversity is still a challenge. And it is measured in different ways. It's not reported the same way by different institutions, and it's not always robust in the way it's reported. So here I think research has still a very important role to play.
Thank you. Question to Anne? Please.
Again, thank you so much for the very illustrative presentation with regards to the assessment of the biodiversity into systems, especially comparing between ruminants and non-ruminants. And my concern and my question is about a pasture-based system in ruminants that you have given us the details. But within this system of pasture, the crop residues, you know, that you haven't really mentioned or presented in details. I'd like to hear more of your comments or your further elaboration with the use of crop residues that has been traditionally, you know, used by the smallholder farmers, especially in the long dry season. In the Asian context, especially like in India with dairy buffaloes, and in China, in Vietnam, coming more and more increasingly using the rice straw, which is a byproduct from the cultivation. That would be increasingly, you know, more important for the feeding systems. How would you apply, you know, with the use of the crop residues, especially the rice straw or sugar canes as such? Thank you.
Thank you. Yeah, it's very important, and I think we saw this morning in the total feed basket at global level. So crop residues are about 19-20% of the dry matter consumed already by the global livestock sector, and mostly by ruminants. This being said, there's room for more. In many cases, crop residues are not used to their optimum. And in low-input tropical livestock system, there's some work to be done to reach this potential. And what can be done, for example, what we do at the moment in projects is to provide equipment for chopping these crop residues to improve the quality of the feed for distribution to the animals, or other forms of conservation or processing technique for crop residues. And this not only increases the potential for this feed that in many cases is still lost, it's not used, it's suboptimally used, but also it makes it more digestible, so it has a positive impact on enteric fermentation as well. And finally, it's something that is no competition with human food, or that is already produced in a way that doesn't have an extra impact on biodiversity, for example.
Thank you. Another last question? Yeah, please.
Yes, I'm Jerry Scherson, animal science at the University of Minnesota. One of the concepts that I find really intriguing is the idea of rewilding. There have been some recent papers in Nature and some other journals talking about, I'll use North America as an example of restoring the bison population on the Great Plains and its impacts on carbon sequestration, and there are some models predicting that some of the key species that have been depleted in various continents around the world, if they were restored to some degree, it would have a tremendous impact on a number of things through biodiversity changes and carbon emissions and greenhouse gases. Have you considered the concept of rewilding, or to what extent do we have agricultural animal species integrated with wild species and sort of these complex dynamics? I'm just interested in your comments. Thank you.
Thank you, that's a good question. I'm not an expert in that, especially in the example that you gave about the bisons in the Great Plains. But I can mention maybe two other cases. So in another quite old areas of the world, like Europe, for example, and this dates back from 20 years ago when I did my PhD on pastoral systems in the Alps or in the Pyrenees, the rewilding that is happening, that is naturally happening at the moment because we reduce the pressure from the ruminants, is actually not beneficial for biodiversity or other ecosystem services. In this case, because we have such a long history of managed grasslands in this case. Then you have other cases, for example, in the savannas of Africa, but I'm sure there are better experts than me in the room to talk about this. But what we see is that we haven't had a replacement of one-to-one between the wild herbivores and the domestic livestock, but to some extent there's been a replacement, and the savannas have been used more and more for the livestock and less for the wild herbivores. One important thing to consider if it's about reintroducing wild species, and this is already the case in many places, for example in sub-Saharan Africa, where you have this livestock-wildlife interaction, and we're going to talk about that, I think, but then you increase also some risk in terms of animal health and human health and one health in general. So there's a lot more to manage here, but it's definitely something that is happening and that is considered and should be better evaluated, I think, from these different perspectives.
Thank you again, Anne.
Thank you.
I think it's time for coffee break. So, Philippe, I imagine we have coffee break and we come back at 4:30.
Coffee break in half an hour. I'm sure now that we will have a coffee more rapidly, so we'll be back at 4:30. Okay? Thank you.